Welcome to qnawire.
Okay, first we can set out the energy balance equation. So we have E dot in is equal to E dot out. If we expand it, we have M dot 1 H1 plus M dot 2 H2 is equal to M dot 3 H3. M dot 1 here is the mass flow rate for the first ideal gas, and H1 is the enthalpy for the ideal gas. And M2 dot here is the mass flow rate for the second ideal gas, and H2 is the enthalpy for the second ideal gas. M3 dot here is the mass flow rate for the mixture, and H3 is the final enthalpy or the enthalpy for the mixture. So now we can do some arrangement here. So we have H3 is equal to M1 dot H1 plus M2 dot H2 divided by M3 dot. Then we know H1 is equal to CpT1. Cp here is the specific heat for the gas, okay? And T1 is the temperature for the first ideal gas. And H2 can be expressed as CpT2. And we know T2 is the temperature for the second ideal gas. And then H3 can be expressed as CpT3, and T3 is the temperature for the mixture. So now let's plug it back to the equation. So we have CpT3 is equal to M1 dot times CpT1 plus M2 dot times CpT2, and then over M3 dot. And then we know this can be equal to, we can take Cp out, so it's Cp times M1 dot T1 plus M2 dot T2, and then over M3 dot. And then we can divide by Cp on each side. So I have T3 is equal to CpM3 dot in the bottom, and what's up there is Cp times M1 dot times T1, and then plus M2 dot times T2. And then as you can tell, Cp here can be cancelled out, and this will give us T3 is equal to M1 dot T1 plus M2 dot T2 over M3 dot. And this can be equal to M1 dot over M3 dot times T1 plus M2 dot over M3 dot times T2. So this is the simplest expression for the mixture temperature, okay? And this is the answer for this question.